Hello, myself Sandeep Bhatt, Assistant Professor, Department of Electronics and Telecommunication Engineering, Runta College of Engineering and Technology, Bhilai, affiliated to Chhattisgarh Swami Vivekanand Technical University, Bhilai. Welcome you course on Fundamental of Communication and its application. Today's our topic of discussion is generation of mobile communication, that is first generation to fifth generation. Hope you all learn about the basic overview of mobile communication in previous lecture. The content of these lectures are the objective of the lectures, wireless communication standards, their features. Now, let us come with the objective of this lecture. After reviewing this lecture, you will be able to understand some historical background of wireless communication, generation of the wireless, that is first generation to fifth generation, and some features of the LTE and VoLTE systems. Now, let us come with some historical background. As we know, the cellular telephone, it was started in the 1940, and after some revolutions, the 1970, we got so many standardizations during the time. In history of wireless, although it has been known for more than century, the mobile networks were widely developed until 1970s. The initial mobile network generation, or we may say as a first generation, somewhere you will find zero generation, where analog networks that supported simple voice communications. Soon after, the second generation, we may say as a digital network appears, offering faster data transfer and improved call qualities. The development of the temporary internet that was used today was made possible by the even faster speed and greater coverage of 3G and 4G network. With its large capacity and incredibly high speed, 5G wireless technology is now the most revolutionary and advanced type of available. Wireless technology has come a long way in existing journey and will only get better. Now, let us talk with the first generation, what exactly happening in the first generation, how was the system, how was that cellular system. The first generation, or we may say as the first 1G, wireless technology was significant advancement in communication. It set the foundation for the incredible wireless technology we use today and was the first steps in bringing people together throughout the world. First generation technology, which was created in early 1980s. Actually, it was started, we say, as the 1970s, and it will take complete 10 years to set up the standards. That's why the GSM at the same time we having 1980s. In 1980s, it offered the analog cellular system. Although the utilization of radio frequencies, users were able to send and receive signals during the mobile phone calls. It made two-way communication possible as well. Now that we know in 70 to 80, there are so many standardization developed, and after that we have the kind of first generation system. We having only single tower for the city, and it will communicate with the mobile. Now, what was the feature of that first generation technology? The main feature of first generation was ability to make call from any location. Because of this, it has become popular for both personal and business purpose. Therefore, it offered a great deal of convenience for people who travel or needed to stay connected on the go. The second features of this is the transmission speed of first generation technology were quite low, usually maximum at 9.6 kbps. This means that the usage was limited and it wasn't suitable for more complex applications. The first generation wireless communication system used the frequency division multiple access. That time the frequency division multiple access, that is FDMA, was introduced and has the multiple access technologies. There are again different technologies, the CDMA, FDMA, TDMA likewise. FDMA is a analog transmission techniques that is inherently narrowband. The service offered by both first generation and second generation system is predominantly voice. That time we have only voice communication, no SMS, and it was completely analogous. Later on it will comes in a digital. For the first and second generation, the main initiative has been originated in North America, Europe and Japan. Although all region uses similar technology, the system differed in their location of the frequency bands in the radio spectrum that we already discussed there are so many frequency regulations, the country wise, that is has been given by the FCC. So, every country having there some rules and regulations for the use of the bands, the channel spacing and the data transmission rate. The first generation solution system, if you find here, the spectrum for it was completely based on the FDMA system. The first system you will find here, we will discuss in with the help of, or we may say as on the base of FDMA, that is AMPS in America and Australia. AMPS is America and Australia make use of such kind of techniques, that is advanced mobile phone system. It is nothing but a AMPS with 25 megahertz band in each uplink transmission from 824 to 849 megahertz and 25 megahertz band in each downlink transmission from 869 to 894 megahertz. You can find here the uplink frequency is less as compared to the downlink frequency. The reason is what exactly? The battery or the power available at the mobile phone is less as compared to the transmitter. That is why we having the uplink frequency at the mobile is low as compared to the downlink frequency. AMPS uses channel spacing of 30 kilohertz with the total capacity of 830 channels and sometimes support a data transmission rate of 10 kbps per second. Second system in Europe is, that is ETACS system. ETA system means the European uses the European Total Access Communication System, that is ETACS, with 25 megahertz band in the uplink transmission from 890 to 915 megahertz and the 25 megahertz band in the downlink, that is transmission from 935 to 960 megahertz. ETAS uses the channel spacing of 25 kilohertz with total capacity of 1000 channels and sometimes support a data transmission rate of 8 kbps. In Japan, that time we have an NTT system. NTT means the Nippon Telephone and Telegraph, which employs the 15 megahertz bands in uplink transmission from 925 to 940 megahertz and 15 megahertz band in the downlink transmission from 870 to 885 megahertz with a channel spacing of 25 kilohertz. The BART system has total capacity of 600 channels and supports a data transmission rate of 0.3 kbps. So, here you will find different countries having different systems and there are different bands and different data rates. Later on, NTT system was modified to enhance its capacity from 600 to 2400 channels. This enhancement was achieved by decreasing the channel spacing from 25 to, now we gone through the first generation exactly. Let us talk about something second generation. Actually, before second generation, the system just started with the digital one. The second generation cellular system, that is completely digital. These systems or this cellular system employs either TDMA or CDMA. TDMA means time division multiple access or CDMA means code division multiple access. These multiple access technology we use in a second generation. Digital telephony allows the greater sharing of radio waves, hardware in base station among the multiple users and provides a larger capacity to support more users per base station per megahertz of spectrum as compared to analog system. Previously, in analog system, we know that there was a limitation of the users. We have a very limited users at the same time. Now, in a digital, once we get this TDMA and CDMA, nowadays you will find we have a FDD and TDD channel. FDD means frequency division duplex and type division duplex. So, this multiple access is playing a very important roles in the channelizations, or again that is the impact on the data rates. The digital technology allows greater sharing of radio hardware in base station among the multiple users and provides larger capacity to support more users per base station per megahertz spectrum as compared to analog system. As a matter of fact, digital systems offer a number of advantages over analog system. So, what are those advantages? Digital system provides natural integration with the evolution of digital wireless network. Digital system provides flexibility for supporting multimedia services. Digital system provides flexibility for capacity expansion. Again, that is, it provides the reduction of RF transmission power. It provides the encryption for communication privacy. It provides reduction in a system complexity. As discussed earlier, the 2G, that is the second generation cellular system, uses either TDMA or CDMA access technology. Code division multiple access standards is strictly North America in the form of IS-95. IS-95 is the INSTIM standard 95 where we use the CDMA system, whereas TDMA deployment is generally based, that is Europe, America and Japan. In Europe, it is a pan-Europe, that is called as the GSM Group Special Mobile System. Nowadays we call as a global system for mobile communication. The first name was GSM is Group Special Mobile System, and DCS system is 1800, that is Digital Cellular System, even we called as a GSM. In North America, it is IS-54 and IS-136 apart from this IS-95. In Japan, it is PDC, that is called as a Personal Digital Cellular System. The different second generation standards have something special, or we may have some specialization or specification we can discuss here. The first system is GSM in Europe. The channel time in TDMA is partitioned into frames. Each frame consists of 8 time slot. Each time slot is of 0.57 millisecond duration. Each users transmit periodically in every 8 slot and receive in the corresponding slot. The modulation scheme used in Gaussian filter minimum shift keying, that is we use here again digital modulation techniques, that is GMSK. IS-54 in North America, that is in the frequency domain, the channel spacing is 30 kHz and the same as that of AMPS. Here we use DQPSK modulation techniques. The speech code rate is 7.95 kbps or 13 kbps with error protection. The capacity of each frequency channel is 3 times that of AMPS. PDC in Japan, its system is completely based on TDMA system. It is having the 3 slot multiplex onto each carrier, similar is IS-9054. The speech coded operates at the full rate of 6.7 kbps or 11.2 kbps with error protection. Now, let us discuss about something with third generation. In the second generation, you will find there are so many limitations, that is we cannot having the video call through this second generation. Even the problem is a very low data rate. This data rate will be, the low data rate problem will be what we say as overcome with this 3G. 3G is exactly the third generation and were initiated in Europe, in North America under respective names, that is IMT 200. IMT 200 is a standard that is described 3G system, and EDMA 2000. IMT 2000 is a wideband, that is direct sequence code division multiple access system, that is DSCDMA, while CDMA 200 is a carrier code division multiple access, that is we call as a multi-carrier system. Multi-carrier system that is used in 3G with the help of OFDM system. IU2 has adopted the recommendation for both IMT 2000 and EDMA 2000 under the banner of Harmonized Global 3G, that is G3G. Both IMT 2000 and CDMA 2000 use frequency division duplex, that is FDD, to support two-way transmission with frequency isolation. Time division duplex has also been suggested as a third generation mobile. It is likely that third generation cellular system will be equipped with the infrastructure to support personal communication system, that is PCS. The network infrastructure support will likely includes, you will find there are different blocks in a third generation the network, that is the public land mobile network, that is PLMNS. Second one is mobile internet protocol, mobile IP. Third one is wireless asynchronous transmission mode, WATM, and the low earth orbit LEO satellite network. Now, if you see about this third generation and is having the capacity of video call, just this because of the high data rate transmission. The most attractive features of 3G compared to 2G are the higher transmission rate, support of multimedia services. The higher transmission rate means that bandwidth of the signal will be large compared with the coherence bandwidth of the propagation channel. When the signal bandwidth is large compared with the coherent bandwidth of the channel, different frequency component of the signal will experience different fading characteristics. The techniques to combat frequency selective fadings needs to be used in order to attain an acceptable error rate at the output of the cell side receiver. As of now, we have discussed the first generation, second generation and third generation. Second generation and third generation, you will find again there is in middle generation, that is 2.5 generation. That 2.5 generation is nothing but the use of OFDM and CDMA systems and the multi-carrier system. Now let us discuss about the fourth generation system. Nowadays you will find everyone is using 4G mobile phones and 5G mobile phones. During the last 20 years, wireless network have evolved from an analog signal medium wise. Only we have a single system, that is voice communication and low data rate with few kilobytes. The system to the digital multimedia and high data rates tends to 100 of megabytes seconds systems of today. You will find today's data rate is much more as compared to the first generation system. In July 2003, ITU made a requirement of 4G system, that is at the standstill condition, the transmission data rate should be 1 Gbps. At a moving condition, transmission data rate should be 100 Mbps. Any proposed system that can meet this requirement with less bandwidth and higher mobile system speed will be considered. It is a beauty contest with the high speed data system. Many advanced applications for users can be realized. Let us talk about the what approach for the fourth generation system. Fourth generation needs to sometimes and that 3G evolution can't do. Means what are the drawbacks and what are the limitations in third generation that we need to minimize using the fourth generation. Looking at the complexity of the applications content and development of such contents going towards even higher data rates and availability of high data rates everywhere is tense. Thus, one distinguishing factors between 3G and 4G will be data rates, but obvious that everyone knows 3G having a less data rate and 4G having a much more data rate. That is, it's completely again depends upon your handset and at what location you are standing. The implementation and the penetration of fourth generation is expected to help close the gap in medical care, education, information and other area, and substantially contribute to environmental problems and aging society, especially in society penetrated by the 4G systems. Home medical care and remote diagnosis will become common. Checkup by specialist and prescription of the drugs will be enabled at home and underpopulation area based on the high resolution image transmission. This is the beauty of fourth generation. You can make a video call from anywhere with the high quality or high resolutions. Technology and remote surgery, that is the main innovation in medical systems, that doctors can operate from any remote location, that is called as the telemedicine. And virtual hospitals will go residents, doctor will realize. This is what exactly the evolution in fourth generation. In education, multimedia educations using video between remote places, big cities and field work using mobile terminal outdoors are expected to thrive. Furthermore, regardless of differences in the languages used, use of these terminals may make everyday life more convenient. Now let us discuss about the technology profile for fourth generation. The system capacity must at least 10 times greater than its third generation counterpart, and cost per bit must be considered or may decrease to 1/10 or 1/100 of 3G in order to avoid imposing a heavier burden on user associated with expansion of information volume. Additionally, 4G must introduce various qualities of services, that is QoS level, in order to provide many kinds of the best effort multimedia services corresponding to user demands. So 4G is a user demand service, that is it gives a quality of service. Based on that quality of services, there are so many application launches with the 4G. The corresponding demands of, we can say, how that 4G get the evolution get what we say the introduced with the current and the last 10 decades. That 4G we know very well, it was started in 2050s or 2040s with efficiently. The high speed transmission peaked to 50 to 100 megahertz, average is 200 Mbps. The larger capacity, that is 10 times greater than the third generation. The next generation internet support, that is IPv6 QoS. IPv6 means that is it's an internet protocol and version 6, quality of service and seamless service, flexible network architecture. So this is what about the fourth generation core network. So these are the requirement of 4G. Nowadays you can find if you go in a market, you have two types of SIMs. SIMs means the subscriber identity module, what we use for the calling. So there are two types of SIM available nowadays. One is LTE, another is a Vivo LTE. And even the type of mobile you will also available nowadays. One is LTE mobile and another is a Vivo LTE mobile. So what exactly these LTE and Vivo LTE? That everyone well knows about this terminology. In our daily practice, whenever there is a change in networks, we experience that there is a 4G, 3G, 2G, AH, H++, on your mobile screen, and somewhere you will sometimes it is written as a Vivo LTE and sometimes it is written as a LTE. So what this exactly LTE and Vivo LTE? It's a technology, that is LTE and Vivo LTE are technology that are quickly being adopted worldwide. They are available in a different frequencies, which is important factor to consider when a decision has to be made on which technology to use. LTE is a high speed mobile data terminology, that is LTE, the full form of LTE is long term evolution, and has been developed together by 3GPP and ITU. 3GPP is a third generation partnership project and ITU is a International Telecommunication Unions. So in the coordination with the 3GPP and ITU, the LTE system get built up. It is based on the existing 3G network and the technologies, whereas it supports much higher data rates compared to those supported by 2G. LTE is an evolution of UMTS, that is the Universal Mobile Telephone System. Then the LTE standards operate at a frequency of 800 MHz for regular cellular system and 1.9 GHz for extended range. Nowadays you will find we have 800 MHz band, 900 MHz band, even 1700 MHz band, 1800 MHz band, 1900, 20, 21, 2300 MHz band. So what are the benefits of these LTE systems? We have that VLTE and Vivo LTE. So LTE offers the great speed and data capacity, which are main reason why mobile operators are switching to this technology. Other benefits LTEs are it improve the coverage area. Previously it was the limited coverage area and even the mobile is in coverage but it could not make a call through these LTE systems. That time you may get 3G or 4G systems, but nowadays this LTE having the great coverage area and within that range even mobile receivers can connect with these systems. Additional security that is provided in LTE, the better network management is also there and some improvement of the services. Now let us talk about what is Vivo LTE, that even this Vivo LTE knows everyone. Vivo LTE stand for the Voice over LTE system. Voice over LTE system, it is a form of voice over internet protocol, that is VoIP. You know very well, nowadays we are calling through the WhatsApp, through internet. So what exactly is internet calling? Internet calling is completely based on the VoIP system, that is voice over internet protocol. It combines the second generation GPRS technology with high data rates that are being used in third generation network. GPRS means General Packet Radio System, and combined with other IP based technology such as audio video streaming and IP telephony. So VoIP applications, these are the different applications nowadays. This has allowed phone calls to be carried through a data connections instead of traditional circuit switch 1. So this exactly we have already discussed the first, second generation and third generation, but the starting of this internet is the foundation with the circuit switching. Without such circuit switching, we cannot go with for the packet switching. So, there are two evolutions during the time. At the time of telephone, it was the first circuit switching. So, circuit switching means we having a simple relays and wires and cables are there. So, this is nothing but a circuit switching, and packet switching is completely used for transmission of packet through that circuits. So, these two technologies innovations are the best key technologies for the telephone and the VoIP systems. So, completely based on the data packets. So, for data packets we need a high data rates, and that data rate can be increases with this LTE and VoLTE system. So, there are so many VoIP applications nowadays you will find in your mobile. This allows the phone calls to be carried through a data connection instead of traditional circuit switching, that is we already discussed. Now, let us discuss something about the benefit of VoLTE. The major benefit of this technology is that it is offer more efficient use of resources. This means that operator can quickly transfer call from the IP network to the circuit switching one, depending on the demand and availability of the resources. So, this is what about the fourth generation LTE and VoLTE system. Nowadays, the maximum telephones or maximum smartphones are completely, or the service provider like in India you will find Airtel, Vodafone, that is, and Jio, Reliance Jio. These are switching with the VoLTE. Even the mobile phone manufacturer like the even India and out of India, Samsungs are there, Oppo systems are there, Motorola systems are there, Ericssons are there. All those the big companies, they are nowadays they are manufacturing the fifth generation, fourth generation LTE and VoLTE based systems. So, that every mobile or any mobile that can the compatible with any kind of system, and these are the international standards. Now, as of now we have discussed the first generation to fourth generation. Now, let us come with the evolution of fifth generation. The fifth generation technology is the latest generation of the wireless technology and is currently being rolled out. It is capable of handling data transmission up to 10 Gbps per second, which is 100 times faster than 4G technology. This technology will enable users to access internet more quickly, streaming video in ultra high definition, access virtual and augmented reality applications. Now, let us discuss some features of this fifth generation technology. The main feature of this fifth generation technology are its incredibly fast speed, low latency, massive capacity and improved reliability. 5G can provide a speed up to 10 Gbps, which is 100 times faster than the average home broadband connection. This means that users can enjoy high quality streaming services without any buffering or lag. Another is it also offers low latency, which is important for applications such as gaming and virtual reality. 5G is also capable of supporting massive number of devices and users simultaneously. Now, let us talk something about the inventions of this fifth generation. Who is the key inventor of this fifth generation? That no one single company or person own 5G. It means, but there are several companies within the mobile ecosystem that are contributing to bringing 5G to the life. Qualcomm has played a major role in inventing the many foundational technologies that drives the industry forward and make use of fifth generation, the next wireless standard. We are at the heart of third generation partnership project 3GPP, the industry organizations that define the global specification for 3G, that is UMTS, including HSPA, 4G, LTE and 5G technology. 3GPP is driving many essential innovations across all aspects of fifth generation design, from air interface to the service ladder. The other 3GPP 5G members range from infrastructure vendor and component devices manufacturer to mobile network operators and vertical services providers. Let us see something, the technology upliftment of fifth generation. 5G is uplifted, or we may say as the key technology behind the 5G is OFDM system, that is orthogonal frequency division multiple access. This is the method of modulation the digital across the several different channels to reduce interference. 5G uses 5G NR air interface analogous OFDM principles. The 5G also uses wider bandwidth technologies such as the sub 6 GHz and millimeter waves. Like 4G LTE, 5G OFDM operates based on some mobile networking principles. However, a new 5G NR air interface can further enhance OFDM to deliver a much higher degree of flexibility and scalability. This could provide more 5G access to more people and things for the variety of different use cases. Now let us see something the beyond mobile internet, that is the 5G, and the beyond this 5G you will find what are the applications of the systems that you will find here. It's complete digital transformation. It enables the various automation sectors. It also supports the artificial intelligence, machine learning, IoT and blockchains, and the society-wide impact on the healthcare, the transportation and many more. You will find every country having their which they adopted the 5th generation system, they having their different communication speed. In South Korea you will find 360 Mbps, in Taiwan 309 Mbps, United Arab you will find 269 Mbps. So this is exactly we have discussed about the 1st generation to 5th generation. Now let us conclude this lecture. Wireless technology has come a long way since introduction of the 1st generation in 1980s. Later on comes in, you will find in the 2024 the 5th generation we have, and we have already discussed the features of 1st generation to 5th generation, their limitations and their few key points. Finally, the 5G is the most recent generation that promises even faster speed and improved stability. The evolution of wireless technology has been a remarkable journey, and with 5G and possible these are seamlessly endless. Hopefully this article has given you an insight into the world of mobile communication with standardization 1st generation to 5th generation and what it means for the mankind. Thank you for listening the lecture.